what we are looking at here is an inequality, but it's an inequality mixed with an absolute value with an equation. So it just gets really tricky. And before we just answer this directly, I want to answer this by way of analogy. And let's talk about this. If I told you I had the absolute value of a number x, doesn't matter what it is, and I told you this had to be less than 10. Remember that your absolute value represents any number. If this is a number line right here, and this is 0, and this represents -10 and 10. Now, if this number x gets too high, gets too far in the positive direction, then eventually it gets to be greater than 10. So any value over here would not, that would fail that inequality. All right. Now, any number that got, because absolute value takes the distance from 0 and it always turns it into a positive number, I can have -1, 2, 3, all the way up, any decimal along the way. But if I get beyond -10, then all of a sudden that turns into a positive number that's greater than 10 when I take the absolute value of it. So essentially, what I'm showing you is that I could rewrite this inequality right here. I can make it look like this, where x has to be less than 10, but it also has to be greater than -10. So that is a different way of saying the same thing. So if that makes sense, that's our analogy. Now let's go back to our specific problem, where we take the diameter of the pole, subtract 3 from it, and we take the absolute value. And that needs to be less than or equal to 0.001. Now what we can do is, because we just saw what we can, how we can rephrase that with this example, I want to do the same thing here. So now d minus 3 has to be less than or equal to 0.001, but it also has to be greater than or equal to -0.001. And the purpose for doing it this way is now I can treat this just like an equation. Even though it's an inequality, I'm going to add 3 in the middle. And that means I have to add 3, not just to the right, but I also have to add 3 to the left. So these cancel out. 3 plus 0.001 is 3.001. 3 plus -0.001 is the same as 3 minus 0.001, which is 2.999. And oops, I was about to put x, but it's d. The diameter has to fall in that range right there. And you might not have thought through it in that way, but just mathematically, that's one way of looking at it. So the maximum diameter for these poles can be 3.001 centimeters. The answer is K. So a lot of people put H, and this represents the minimum size. And anyways, you can see the process. If you have questions on that, hopefully, or you're able to see where you made a mistake and that answered any questions, but let me know. So we are looking today at factoring quadratics when your a value is greater than 1. And I'm going to say from the beginning that you already know the full process for this, and it might be a little bit, look a little bit more challenging at the beginning, but the fact that we learned pretty much the full process on Monday means that as we go through this, you're going to say, oh, okay, so this only changes it ever so slightly. And maybe you don't even think it changes it at all. But I don't have a presentation here. I'm just going to jump straight over to Delta Math. And I'm just going to go through a couple of examples whenever your a value is not 1. So let me zoom in on this, give some space. And just like we would do with any other problem, I want to go ahead and label my A, B, and C just so I know what numbers I'm working with. So what is A for this problem? 4. What is B? -35. And C is 49. This one's actually going to be, this is a randomly generated one. This is actually going to be, well, a little bit, I don't know if you would say more challenging, but it's going to be a little bit different because we're going to have a big number to work with. All right, so this is one minor difference. And as far as this goes, if you know how to set up your big X, you don't have to write all this other stuff on it like I am. So if you know what you're doing, just write a big X and start filling in the numbers. These other things that I'm showing, the a times c and the b and the plus and the multiply, that's just for your reference as you're watching me go through the problem. Okay, so first of all, let me just put the negative 35 down here. And the top is a times c. Every time before this, it was 1 times c, so we didn't really think about it too much. But now we actually have to do a times c, and what is that? 196. That's 4 times 49. And now what makes this one kind of fun is that we're going to have some big numbers to work with. And this is one where it can get really easy to get lost in what all the factors are of 196. I mean, I don't know all the factors of 196, but what I think is the best way of approaching this is start at 1. So 1 times 196. And then 2 times, and I'm just going to kind of go through it a little bit fast, but 2 times 98. 3 is not a factor, but we could confirm that. We could take our calculator, do 196 divided by 3, see if it works. And we find out, no, it's a decimal. So let me try 4. We already know 4 is, because 4 times 49 will do it. 5 is not going to be a factor. 6 is not going to be a factor. But, and I'm just kind of, here's what I would do. I would just start going through all of my things here. And let's see. So I think we could keep trying. So try 7, then try 8, then try 9. I mean, I don't know all the factors. I'm going to have to take a second to do that. So 196 divided by 8. That 8 is not a factor. 196 divided by 9. Again, that's not a factor. Now, if 3 is not a factor, then 9 wouldn't be. 196 divided by, let's try different numbers. And so this is where it's going to be a little bit time consuming. And actually, a lot of them aren't going to be this time consuming. Have you guys found any other factors? 7 and 28. Okay. 7 and 28. There it is. And then 14 and 14. Now, we only need to go up as high as the square root of this. So if you're thinking like, oh my gosh, 196, I'm going to have to check 67, 68, 69. No, you don't really. You only need to go up as high as the square root. And so you'll notice that 14 times 14 gives us 196. So there's no other number we need to go up to. So there it is. Those are all the factors of 196. So at any rate, now we're looking at these factors. Which two can we multiply to give us 196 and then add to give us negative 35? 7 and 28. And what do we have to do with those?
Make both negative.
There you go. Make both of them negative. So there we are. And we end up with, let me erase this down here. We end up with the same process as before. And it's funny, the first randomly generated one was actually one that took a little bit more work. Because we'll see a lot of these, the numbers don't get quite that big usually. But it's all good to see how it goes, how the process goes. So now we're going to split that negative 35 into, so I got 4x squared minus 7x minus 28x plus 49. All right. So I'm going to go ahead and pull out or put those terms into the Punnett square. So I've got 4x squared minus 7x minus 28x plus 49. And this is the same as before. So this is why I encourage you to keep using the Punnett square even if you felt like you didn't need to. But that's because now we have to. There is no shortcut for a quadratic like this. So let's look at the first column. What's the common factor between 4x squared and negative 28x? 4. 4, absolutely. And x. There we go. So when we're talking about what is a common factor, I can think, here are the factors of 4, 1 and 4. Here are the factors of 28, 1, 4, 7, 20. Well, sorry, there was also 2 and 14. But I can see that 4 is shared by both of those. So that's what I'm going to pull out. All right. So if anything, these get more challenging just because there's bigger numbers and slightly more complex thinking to work through. All right, this column right here, what's a common factor between negative 7x and 49? Negative 7. Now we want to pull out a negative 7 because this term right here, the highest degree, is a negative number. So I want to pull out a negative 7 for that. All right, first row, what's the greatest common factor here? 1x. 4 and 7 don't have any common factors, but they do both have an x right here. And lastly, what's the common factor between negative 28 and 49? Negative 7. Those are both multiples of 7 right here. So they're going to have that in common. There's nothing bigger that they have in common as a multiple, or sorry, as a factor. And we want to pull out the negative because that first term, the negative 28x, is negative. All right, that's it. You've done it. 4x minus 7 and x minus 7. Now, these are ones where you might want to actually stop and confirm that you did it correctly. So you might want to actually go out and do the distribution again. So I'm going to do 4x times x, so 4x squared. The next one would be minus 28x. The next, when I do the negative 7 distributed, it's going to be minus 7x plus 49. And then we can go through and we can combine that together, and we get 4x squared minus 35x plus 49, which is what we started with. So it all worked out. We're good. Okay, so let me go ahead and put a box around that. That's our answer. I'm going to submit it, and then we'll do another example. The order of our factors doesn't matter, so I'll go ahead and put the x minus 7 first, and then the 4x minus 7. And there it is. We got it right. So this process that's taking us as a class a little bit longer because I'm going through every single step, you can get to the point where you can do it much faster than this. Let me just pull up. We're getting a lot of these that are similar. Okay, here we go. Now with the level 3 stuff, we're going to have positives and negatives. So that's okay. You can handle it. You know the process. Let me zoom in, give us some space to work with. All right, there we go. So A, B, and C. What have we got for A? 6. Actually, you know what? I don't want to do this problem. I take that back because that's going to be another big number. You will have some like that, but I just wanted to. Do you want to do this one? See what it's like? Give it a go. Okay. You know what? We're going to test ourselves. Okay. We're doing it. Negative 37, negative 35. Big X, A times C, B. So go ahead and fill in the X with the A times C and the B. And of course, I hope you guys have some paper out so you're able to do this work on your own. Okay, we got that. So just as a trick here, because this is negative 210, the square root of that, I just found out the square root of 210 is 14.49. And that means when I'm checking, I can check 1, 2, 3, 4, all the way up to 14. But that's as high as I need to go on the left side. If any of these are factors, I can find that out. But once I get to 14, I can stop. All right. So we already know what summate factors are going to be. 1 times 210. 2 times what? All right. So that's it. Those are all the factors. All right. And luckily, if the number isn't super big at the top, like 210, then it won't take as long to do this part of it. So we're going to have a positive and a negative factor that we're multiplying together to give us a negative product. How are we going to make this work so we can do a positive and a negative that will multiply to give us 210 and add to give us negative 37? 5 and 42. What's going to be negative here? Perfect. Again, this is a big step up from maybe some of the first quadratics we were doing. But now negative 42 times 5, we know is going to be 210. Negative 42 plus 5 is going to be negative 37. We've just done the hard part of this. And now it's just going to be 6x squared minus 37x minus 35. Split this middle term into plus 5x minus 42x minus 35, and do the Punnett square. So I've got 6x squared plus 5x minus 42x minus 35. All right. So let's go ahead and pull out a common factor. Let's start with the rows. What's the common factor between in the first row? 1 and x. There we go. We can pull out an x because we can see an x here and there, but there's nothing number-wise besides 1 that we can pull out. Second row, what's common here? Seven, there we go. We can see that 7 is a factor of both of these. And because 7 times 6 is 42, 7 times 5 is 35. So 7 is going to be a factor. Is it going to be a positive or negative 7? Negative 7. Again, whatever this bigger variable is, that's going to be the positive. We make a positive or negative based on that. Okay, first column. What's a common factor? 6x, and it will be a positive 6x because the x squared is positive. And the common factor here will be 5. Again, you might not work as quickly on this, but I'm going to pause right there to make sure everyone's feeling comfortable with the numbers we got. Okay. So with this, we've got our two factors, 6x squared plus 5, x minus 7. I highly encourage you every time to go ahead and double check. That shouldn't be x squared. I apologize. See, I made a mistake. I highly encourage you every time to go ahead and double check your work by doing the distribution over again and making sure you get this right. I'll go ahead and tell you, if I do that again, I will get 6x squared minus 37x minus 35. All right, but I encourage you to do the distribution like we started with in this unit to make sure that you have the right answer. So let me go ahead and plug this in. 6x plus 5. That's supposed to be in parentheses. And then it'll be x minus 7. All right, there it is. And we got it. There it is. So at this point, what I'm going to do is I'm going to stop recording. I'm going to allow you guys, if you're done and you think you know what to do and you're not having any troubles, then you can go ahead and log off, call it a day. You have your Delta Math homework to do, and good luck with that. If you want to stick around to get one more example, feel free to do so, and we'll just pick another random one and do this one more time. So with that, if you're good to go, have a wonderful day, and I'll see you tomorrow.